Hello. So in this video, I'm going to be sharing the details of the AI toolkit and all its parameter. The goal here is really to understand how each of these parameters are set, because there's a lot of them and it's important to understand what each of them means and what does it do. It will enable you to better understand what needs to be changed, configured, updated to match your use case there, because most of these settings it's matching my need, but in your case, if you want to change it so that it matches your specific use case, understanding this will help you out there. So let's go through this and look at each of these parameters, what it means and what to set basically. So let's start with the job setting. So in the job setting here on the top left, we can see there's a training name. So choose the name of your training job. After that, we have the GPU ID. If you only have one GPU, then you just select the default one. If you have more than one, then you can select the one that you want to use to train there. You cannot use both of them to train at the same time. You can just train with one of the GPU at a time there. So select the biggest one that you have. For the trigger word, for now I leave it empty because I'm not creating LoRA that has multiple characters or multiple elements that I want to trigger them independently. For now, as you saw from my first video, I just put a character in there with a word, and I just use that to trigger the whole LoRA there. So there's no need to use trigger word. But for more advanced usage of multiple elements mixed together in the data set that you want to trigger them accordingly, in that case, using the trigger word will be important there. So let's go into the model configuration. So in here, we can see there's multiple model that you can train. We're going to be mostly focusing on the video Wan 2.1, but you can see there's a lot of other element that can be trained there, from Flux to Hydrogen to SDXL and so on, right? Even Wan 2.1 right now, it's the one that we have available, but I'm sure in a matter of time there we'll have the 2.2 also, so that we can start training with that and so on. So just keep updating this GitHub there with the code, and you'll get newer version as they come out. So that's for the model there. And name and path, it's fine. Here you have the quantize for transformer and text encoder. Now, quantize really means is you're compressing it. You're using a version that is not the full uncompressed version, right? You want the version that is quantized so that it maximize, or rather it minimize your usage of the VRAM, right? I mean, the VRAM, it's something you have very limited, and compressing it, these elements would make sure that you're maximizing your use of that VRAM there. Again, in my case, I have only 24 gig of VRAM. I need to make sure that I enable all the element that allows for the minimum usage of VRAM, so that I can be as fast as possible when I do the training there. So I do enable the quantization. If you have way more VRAM than me, you can keep the non-quantized. The result will be slightly better, or if not a lot better, I'm not sure, but you need a good amount of VRAM for it. So keep that in mind. Same thing here, I enable the low VRAM so that it really maximizes my VRAM. It really allows it to move some element to the CPU when you want to save a bit of GPU VRAM there. It avoids storing some data in VRAM when it's not needed, or it can even load things that is only necessary when it's needed there, so that it doesn't load everything at the same time. Again, usually in most of the parameter, it's a balance between the VRAM memory, the speed, and the quality of the training. So you have to kind of balance them out, right? I mean, do you want to save a bit of VRAM? In that case, you might affect the quality, you might affect the speed of training, and so on, right? So you have to balance them out there according to your priorities. Okay, so let's look into target configuration. In target configuration, you have the type, right? I mean, you have LoRa, you have the low KR there, but in our case, we're training LoRa. So the linear array really enables the quality of your LoRa being trained there, right? So in a low value of linear rank here, you'll have something that is very fast to train, but at the same time, it won't be as strong, right? The style won't come out as strong there. While if you put a high value, like right now I have a 32 linear rank, it will be the very strong LoRa that you're going to be getting there. You'll get all the little details, the nuances, and the style that's going to be coming out there. But it does take longer to train, right? So that's why you have to choose. Do you want to go very small value, like a 2 to 8 value there, or you want to go something very high, like 32 or even higher than 32, knowing that it's going to take more time to train there. So it's a choice to be made there. But keep in mind, I mean, the whole point of the LoRa is to have that add-on to your main initial model, right? So you want that character to come out. But I mean, if your character is very simplistic, maybe you don't need that much of the high rank there. But if you have a lot of details that you want to come out from your character, put it high so that you can get something good. So let's go into say configuration. You have data type, you have save every. So data type, I mean, if you want to save some VRAM there, make sure you choose a low data type like the BF16. So let's look into save configuration. So in here you have the bit float, floating point 16, floating point 32. So basically this is really where you choose the precision of your LoRa there, right? I mean, how much, let's say, detailed data that you give it so that it can remember the weights there, right? Giving a lot of data for each of the weights there is good, but at the same time, it's going to take a lot of that that memory there, that VRAM memory. Not for necessary for the training. It's more about the when you load the LoRa itself there. If your LoRa is very big, then you can see how during the generation, the inference there, it's going to take up a lot of your VRAM, right? So the highest quality obviously is floating point 32. You'll have a lot of data for each of the weights there, but it also means a lot of usage of VRAM there. Floating point 16 is the middle there. There's the bit float 16. I mean, it's only available if you have more of the more recent GPU card there, right? If yes, do use this. It's probably the best one to use there, but only if you have those latest GPU there. So in my case, I have a 3090, so I can actually use the bitflow 16 there. So I'll use that to minimize the usage of the VRAM there. Save every there, I mean, I put a very high value. Otherwise, when you run this and you put a lower value, basically what's going to do is it's going to try to save a version of your LoRa as a copy at every X steps, basically, right? So let's say I put 10 here, and I do, let's say, 100 steps for my training. What's going to do is that every 10 step, it's going to save a copy of that LoRa version in the file, basically. So why would we do this? I mean, let's say you want to actually see, what does it look like between X amount of steps there, right? So at every 10 step, you want to see a version of that LoRa so that you can see how much training happened and what is the result of such a training there. So you put a version here. In my case, I want to fully control how much I want to see, and when I save it, I basically just go on the folder. I do a copy paste and save the file there somewhere. So basically, I control that. So I just put a very high value there, knowing I'm never going to reach there. There's also right now the max step, right? So think of it as a round table of whenever you save a file, if that file has already being saved for multiple times, it's going to start deleting the older ones, right? So it just keeps the last, in this case, the last 4. In my case, it doesn't matter there. I mean, I'm not even using this, but let's say you're putting a lot of save in between there. Like, let's say you put 10 here, so there's going to be 10 of them being saved if you have 100 step. Well, putting 4 here means that every 4th one there is going to start deleting the older ones, so, right? So it's just only going to keep the last 4 safe tensor for LoRa there, and not keep the older one, so that you don't keep every version of those LoRa files there. Okay, now let's go into the training configuration, which is very interesting here. Now, batch size is considered. So max step save to keep. I mean, for this value there, it's really just how many of the LoRa file you want to keep from the most recent one, right? So if you start to generate multiple ones, and again, this is there to save this space, right? So let's say you're generating at every 10 steps there, right? You're gonna save a copy. Once you save already 4, on the 5th one that you're saving, it's gonna start deleting the oldest one. So you only keep 4 at max there at every training steps, every time it keeps a copy of that file. So let's look into training configuration. So first we have the batch size. So for the batch size here, I mean, think of it as how many of the images in your training data set that you want to process at a time, right? So higher batch size means you're going to process multiple images at the same time, which in theory should save you training time. But that is only works if you have enough VRAM, right? Because it's going to put more of that data into the VRAM there to do the training at the same time. So again, in my case, I could not use batch size of 2 there. I'll go back to 1 because it was going over my VRAM, right? So it was not making it go faster. Knowing that it's training multiple images at the same time, it was making it slower because I didn't have enough VRAM. So in my case, with a 3090 and for 24 gig of VRAM there, I'm going to use 1. Gradient accumulation, I mean, this is similar to batch size, but it's more of a simulation as if you can do multiple image at a time there. Basically, it's going to delay the weight update there, so a bit slowing down the training so that you can do multiple image at the same time when you do the training. Now, why would you do this there? I mean, obviously it's you don't have enough VRAM, but you still want to do multiple batch size at the same time. But knowing that it's not going to necessarily make it go faster, one of the element here also with the batch size is it's known that having multiple images at the same time could increase the quality also. So that's why you might want to do this, even though it might not go faster. Again, it depends there. I mean, on the VRAM that you have there. In my case, I didn't play around with this a lot yet there, so I'm leaving it as 1. But in the future, I'm going to be playing with this to see if I'm getting better result there. Now, step. This is one of the key element you're going to be using a lot there, right? I mean, this is how many training step are you putting in to make sure that you have that gain of LoRa training. Basically, for the steps here, I mean, think of it as how long I'm going to be training my my LoRa here. If you put a very low value for the step, obviously it won't have enough iteration and time to learn about your character, right? Versus if you have very high step here, then it will have that amount of iteration necessary to learn about your character. Again, it depends on a few things. I mean, usually 1000 would be something that would be a LoRa that's lightly trained, right? I mean, if you have something very simplistic, maybe that's good enough. A good LoRa, a good balance of step here is 3000 to 6000 here, right? I mean, within 3000 to 6000, you should have a pretty good LoRa been generated. And if you want to go really high end there, I mean, you can go even to the 10,000, even more steps there, so that you can train some very complex LoRa there, a lot of details, a lot of quality, or even maybe because you have a lot of data in your data set, right? I mean, if there's a lot of data in there, maybe you want to give it enough of the time there, enough of the steps, so that it fully trains itself and learn about your data set. For the optimizer, I mean, really, it's how does the LoRa learns, right? I mean, it has to learn at every step there, and depending on your optimizer, it will learn in a different way to go and update your weights there, right? So it's all about the weight at the end, right? When you think about it there. So for now, I just use the default one here. I didn't have time to play with the other one, but there's could be multiple ways to learn there on the optimizer. Learning rate, I mean, you have to put this at a, with the learning rate there, I mean, it's basically how fast does your training happens, right? I mean, how much of the weight do you want it to be impacted and updated at every steps there, right? So you don't want it to be training too fast, because becoming training too fast might make it unstable, right? It might not converge to your character there. You'll be a bit confused basically, right? But if you put it too slow, well, it'll take a huge amount of time to learn, right? To train itself there. And even it might be get stuck and not be able to reach neither the actual result, right? So that's why you want a value that is something like this. I mean, these are usually the default value there. I mean, if you want to be even more precise there, you can even go a bit lower or higher depending on how you have your data set up there and how detailed is your character, right? So this is the default value. I'm going to leave it like that. Weight decay, basically, it's a technique, and this is because we're using the optimizer Adam W there. I mean, with the weight decay, it's a fundamental element that basically starts to lose some of the weights there at every step, right? So the point here is, think about when you're learning things and you see things in nature, in your surrounding. I mean, you want to make sure that you just don't copy that information and that's it. You're learning the concept of it. So really here what it does is, you don't want it to just use your training data set there and say, hey, this is my character, and whenever something happened, I just paste the whole picture that I saw there and paste it over, right? I mean, you really want to understand the LoRa, to understand the concept of what is your character about, how is the eyes, the hair, and so on, so that it can adapt those weights toward the main model, right? So again, it's not about memorizing the image, right? The fundamentals of AI models there is not copy the data, right? It's really to train on the data with the weights there, so that you can adapt to your situation there based on the prompt, based on the different input image and so on there, so that you get the result that you want there. So again, it's not about memorizing the data, it's about learning about the data. So that's why to have a decay allows you to slowly forget whatever that was finally not that important. I mean, it looks at the image there and it's like, oh, this seems important. Maybe it remembers it, or rather affect update the weights so that it works for the training there. But if that doesn't come back again, we'll slowly forget it or have a lower impact on the weights there. So weight decay, a very key element here that you want to put in place there. You want to make sure that it's there. The current value here is rather small for weight decay. Usually for LoRa training, we would put something like 0.01 and not 0.0001. So that's pretty small for weight decay. But again, this was the default value that was here. Using it so far and it's working so far. I'll probably do more testing to see if I can play with this to have a better outcome there of my LoRa there. But for now, I'm leaving it as is. So time step, it's basically a way to manage the different adding and removal of the noise, right? I mean, at the end, you're trying to add that training so that your LoRa can understand how to remove that noise there, to converge toward that character, that image that you would like to see. So that training of adding, removing noise is key to the LoRa training. And that's why having the type of Timestep, the type of training that's being used, it's important here. Same thing for the bias and the noise scheduler, right? I mean, all that is setting on how to add and remove noise at a certain way and aspect there. Do you want to do that in a linear way, in a logarithmic way, in different ways so that it converge or rapidly trains toward what you want to do, right? Again, looking at the time step there, I mean, we can see the different bias time step there with high, low noise. I mean, we're going to see that a bit more with the Wan 2.1 and the flow match, right? I mean, noise scheduler. These are more advanced settings there. I'm going to leave them as is. Next, we have the EMA here, the exponential moving average. Think of this as you update the weights there, having a copy of the weights that are the average ensures that you don't just only train on the current weight, but you keep a average somewhere to train with along with it there, right? So that's why you can use the exponential average there to keep that weight average while you do the training. Now, again, these are advanced technique of training there. You can enable it. Enabling it will give you a better learning, better generalization, and so on. So it's good to enable it, but the disadvantage is going to be using a bit more of the VRAM, and it's going to take a bit more time to train there, right? So again, since I'm trying to minimize on the VRAM there, I'm going to leave it not enable. This is the decay of that EMA there. I mean, you're keeping a copy of that training data as average there. Well, you want it to decay also, so it doesn't do the overfitting like we discussed before. Now let's go into the unload text encoder. You'll notice here I actually enable it, right? The unload text encoder allows you to save a bit of VRAM there by unloading the text encoder from the VRAM memory whenever it's not needed anymore, not used anymore. Now, that being said, I mean, in my case, it's simple because I don't really use the caption for the training data set there. I mean, my training data set is very simple with just one word for the trigger word there. There's no specific on the caption for my data set, so it's not necessarily to keep that in memory there, right? So we can enable the unloading by simply enabling that feature there. Now, in the case where you have more complex captioning there with a lot of trigger words, in that case, you would like to keep it. Otherwise, it won't do it properly there. So keep it if you have more complex LoRa there with multiple style, multiple character, or in a case where it's just something simple, do unload it to save a bit of VRAM memory there. Now for the regularization settings there, for the differential output preservation, this is enabled when you want to do the merging of the LoRa models, or with the main model there, when you do model merges. In our case, we're not doing that there, so I don't think this is necessary to enable. You enable it when you merge, and then you want to keep it separated. You don't want to all mingle the LoRa and the main models together, so that it preserves it. It keeps the main model separated, basically, right? And you can even tell it about the multiplier, and also about what class, what tag you want it to be preserved, what capture you want it to be preserved, right? So that's used in that case. In our case, we're not doing merge of models, so we're not going to be using this there. So let's go down to Dataset. I mean, Dataset itself, it's all your data that you're going to be used to train there. Keep in mind, on our dataset there, it's all image dataset, right? I mean, I'm not using video dataset. You could use video dataset there because we're training Wan. It's just that training with video will be very heavy there, right? I mean, it's gonna take a lot of time to train on video, so that's why, to go the simpler path, I'm going with just image dataset. Now, training with video does have its advantage, right? I mean, right now I'm training a character so that knows what it should be looking like. But if you want to train toward the how should that character be moving, what kind of motion, what kind of transition that the character should be doing there, well, in that case, training on video makes a lot of sense. I'm not gonna go on that path. I just want the character to be showing up with the different characteristic of that character, right? And to keep that consistency going there. So that's why I'm just gonna keep with the image dataset. Here you have the LoRA weight, just put to 1 as the default there. You can put some default caption. You can put some caption dropout rate. I mean, for this one, basically is when you have different caption there in your training data set. Right now, I just have 1 word in there, right? So it's straightforward. But if you had multiple caption and you don't want it to be training on all the caption all the time and not have that flexibility of the different caption and be able to train on different caption there, do enable that dropout rate so that it will basically randomly remove a caption and still train without that caption there, right? So it will improve that training with the data there. You can do also cache the latent there, right? So you can cache the data set there so that you save a bit of memory there, but I didn't see it being very effective when I was using it. So something to be trying still. And same thing for the regularization there. In our case, we're not using it, so it's disabled. Resolution here, I mean, this has a big impact on the dataset size, right? Hence the VRAM usage there. You do want to train on high quality image there, right? But at the same time, it does directly affect your VRAM, right? I mean, and also the speed, right? But then the quality is impacted. So that's the famous balance again, right? We put something in the middle here, right? I mean, 512, 768, 1024. I mean, those are the middle value there. So the data set, no matter what the resolution is for the different image that you added there, it's gonna narrow it down. It's gonna resize it to fit those resolution so that you train on something that is of a normal resolution there. Increase it with those higher ones if you're able to do it, but with this I was able to get some good result there. Now, one last thing is true with the number of frames, right? So again, because we're training with just images, we just leave number of frames to 1, right? I mean, there's no training on multiple frames, right? If you had video to be trained, in that case, you might want to tell it how many frames do you train within each of those data set, right? You put higher frames, obviously it's gonna train more on that motion that you have in those video in the training data set, but it's gonna be take a lot of more time to train, right? So again, that's something that you can evaluate there. In our case, it's image, so we're gonna leave it as 1. For the sample configuration, I'm not gonna go too much detail in this because again, this is just to generate that sample whenever it finished the training. So you can auto configure it to do at every X amount of sample there, of steps, sorry. You can also select different sampler, guidance scale, how many steps you want for data, but all of this has nothing to do with the training itself, right? I mean, this is just a example output so that if you enable it, right, if you, I don't touch the disable sampling, it will run a image generation or video generation. I mean, you can increase the number of frames here so that it will generate a video upon your prompt there. In my case, since I have my own workflow in my ComfyUI there, I prefer to run it there in my ComfyUI workflow because this is where I'm going to be actually running this LoRA, right? So I want to see how does it look in my actual workflow with all my settings that I have in my own ComfyUI workflow and the LoRA usage there. So that's why I usually disable this there, but sometimes just a quick one prompt there and one example from time to time, maybe that's going to be giving you the example of where you're going with this, right? So it might be good to keep if you feel the need for it there. So that's it. That's the whole configuration of a training job for a LoRA. All the settings, we've went through them there. In most of the cases, I mean, keep in mind of what you set so that you minimize the usage of the VRAM, right? I mean, for me, at the beginning there, when I was doing my training, the initial training took a lot of time. You see now I'm at 8 seconds per iteration, but at the beginning I was something in the I don't know, 100 seconds per iteration or something crazy like that there. Why? Because at the beginning I was going over my VRAM memory. I have 24 gig of VRAM here. I was going slightly over. It was just a bit over, but the fact that it was going just a bit over was enough for it to slow greatly down the iteration there, the step training. So make sure you never go over the VRAM so that you benefit from the maximum speed of training there. As soon as you go slightly over it there, it means that you're gonna start using your normal RAM, and that's gonna greatly slow down your training. I mean, one other way to see if you're going over it is to look at your own memory usage there, right? For example, here, if you open up your task manager, right, and you load it up here, you can see your task manager here. There's different things you can check there, CPU, memory, and so on. If you go to your GPU, the one you want to generate with there, you can see the dedicated GPU and the shared GPU. The goal is to stay within the dedicated GPU, which is the memory VRAM of your main GPU there, right? For sure, you have more RAM on your normal machine RAM, but that is way slower, right? So do stay within the dedicated GPU memory, right? If you ever see the shared GPU memory start to go up, that's where you need to change something, to change the setting there so that it doesn't do it, right? So let's give an example here. If I go to this training, and just for an example there, I'm increasing the step to just 3 steps so that we can see this being activated. I'm gonna run this, and we're gonna see the VRAM memory start to go up. And when that happens, we're gonna check the. In fact, I can just load the other one. So can we see both at the same time? There we go. So we can see the GPU load that being used. We can see right here. We can see the VRAM being loaded in there, right? So it's starting to climb here. The goal is to keep it within it, right? I mean, if you ever see it go over here, then that's not good, right? So it's running there. We can see it unload, load, and so on, but it never goes over to a point where it overloads into this shared GPU there, memory. And that's the key element here, to make sure that the iteration and the speed of training is very fast, right? And that, for me, like I mentioned, the way for me to achieve it there was during the configuration of the training there. If I put a new job here, was to enable this, right? Unload text encoder. It saved me, I think, 2 gig and so on there, but that was just enough to be under the bar there, under the overflow to the normal RAM. Are there other things I can change? Probably, right? I mean, linear rank is probably one I can change there. In fact, sorry, just put this to the one there, right? So obviously the low VRAM is all, I enable that for sure. There is some element you can probably change here to make sure that you minimize that VRAM usage. So maybe it's worth to do a little summary, in fact, of all the configuration that would minimize your usage of the VRAM there, knowing that it might impact the speed and also the quality. But let's go through it, and you can make your own decision of what makes sense to reduce or to set there for your own configuration and environment. So the first one obviously is the low VRAM. I mean, that's a pretty obvious one. After that is the, like I mentioned, the unload text encoder, right? I mean, that's one where if you don't have those complex trigger word, complex caption there, definitely something that you can enable to save 2 to 4 gigabyte of VRAM. So do enable that. Use lower precision, right? I mean, the save precision there, I mean, use it as low as possible. Bit float 16 is probably the one that's gonna save you the most VRAM there, so already set. but if you're trying to go something higher, do set it lower there. Reduce image resolution. I mean, the image resolution here, it's something that improves the quality, but also if you go too high, it will also reduce the speed there. It's going to take way more time and also use a lot of VRAM memory, right? So go lower if you want to save a bit of VRAM memory there. You can also, for the batch size there, I mean, going up a bit there, the batch size, I mean, I already set at 1. You can, if you wanted to do something that is faster and potentially higher quality, you can go a bit higher in the batch size, but to put it as low as possible so that you minimize the usage of the VRAM there. Same thing for the EMA there, the exponential moving average. Do not use that. If you want to use it, it's going to give you something higher quality, but it's going to use up a bit more of VRAM memory there. So keep that disabled. The cache latent can help there. I mean, the cache latent here can help a bit there, but I didn't see much of a difference there. In fact, I'm already under the 24 limit there, right? So I don't need to save a bit more. The cache latent there is another trick to save a bit of that VRAM memory there. To enable it when your data set is not changing, right? If it's always the same data set that you don't change, you can enable that cache latent there. And it's going to save a bit of VRAM also. So those are the different settings that's going to help you save a bit of that VRAM there so that you can have the maximum speed for the LoRA training. And maybe an additional element here, if you want to see the details of this, right? I mean, you can click on the show advanced here. It's basically all the details of those settings that you're doing, right? I mean, you're using it as a graphic user interface there, but at the end, this is what it's setting there to be able to do the LoRA training, right? All these different settings that you can see on the background there. But clicking showing simple gives you that interface to interact with those values, basically. Thank you very much, and I'll see you in the next video.